Alright folks, today we're going to talk about preparing for the test. We're putting what we learned the last couple of times together. When we're given a triangle and we're supposed to solve for either a missing side or a missing angle, okay, these are the steps we want to take. Okay, the first thing we want to do is look if it's a right triangle, because with right triangles we can use SOHCAHTOA, okay, or Pythagorean theorem to solve for a missing piece. Right? If it's not a right triangle, we're going to choose either the law of sines or the law of cosines. And the way we decide between the two is whether we can choose one pair or two pairs. Okay, remember a pair is one angle and one side across from each other in the picture. So we're going to start out on number 1. It says find JM. So JM in our picture gets our X. And we're going to go through these questions. First, we'd have to decide if it's a right triangle. Well, we were only given 2 of the angles. We want to see to make sure that this is not a right or a 90-degree angle. Remember, we take 180 and subtract the other 2, minus 25, minus 48. For 107 degrees, that makes it not a right triangle. So then we can pick our pair with X. X goes to 107, and then try to choose another pair. We have another side across from the 48 degrees, so that makes this a law of sines problem. Okay, with the law of sines, we have 2 options for writing it. Okay, if you haven't already, pause the video for a second while you grab out your cheat sheet, because under the trigonometry section it has both the law of sines and the law of cosines formula on there. So grab that out. We'll be using it throughout today. Alright, well, with law of sines or law of cosines, we could put sides or angles on top. Always put your X on top. So X over, since X is a side, we have to put on the bottom our sine of the angle. So that's sine of 107. And then our other pair, 15 is our side, over the sine of our angle, 48. Now we just solve for X. Right now, X is divided by sine 107, so we'll multiply by sine 107 on each side to get rid of that. So then, X equals just the right-hand side, that 15 over sine 48 times the sine 107. Okay. So our answer is 19 here, 0.3. Alright, we have to really pay attention to labels in this chapter. If we're talking about angles, we want to make sure they're labeled in degrees. If we're solving a word problem, we have to label sides with feet, yards, whatever we're working with. So it might be a good idea for you to go ahead and tack on a little units here so you get used to just looking for labels on problems. The next one, we're supposed to solve for DF. DF in the picture is over here. So once again, we want to decide if this is a right triangle. We've got 50 and 60, so we'll take 180 minus 50 minus 60 to get that third angle of 70 degrees. Definitely not a right triangle. None of those are 90, so we'll pick our pair. Once again, we look for a second pair. We may not be able to find one, but we look for one. Okay, and in this case, we do have another pair, 50 and 21. Okay, I want you to pause the video, decide if this is law of sines, law of cosines, and set it up. Since our X is a side, we're putting sides on top. We've got sine 70. On the other side, we've got 21 on top over sine 50. We have 2 pairs, so it's law of sines, just like the last one. Now we just multiply by the denominator, sine 70 on both sides. Over here they cancel, so we just have to type in 21 divided by our sine 50 times our sine 70 for 25.8 as an answer. Again, if you want to tack on units so you don't forget about labels that really matter, you're welcome to do that. Next example, okay, we're solving for BC. Mark your triangle, and we're walking through the same steps. First we look, is it a right triangle? Now, you'll notice on this one it's a little bit different because we're only given 80 degrees. We don't have another angle in here. When we don't have another angle, there's no way to find those missing angles immediately, so we can't assume it's a right triangle. All right, so not a right triangle means law of sines or law of cosines. Let's pick our pair. And because there's no other angles, we cannot choose another one. Okay, so a really big indicator of law of cosines is we cannot choose the second pair. Okay, there's not enough angles, so if you don't have enough angles, it's law of cosines. Now, on your cheat sheet, your law of cosines looks like this. And remember, across from each other is our one pair. With law of sines, we get to pick what goes first. Law of cosines, we cannot switch the order. This says lowercase x, so it means the side has to go first. So in our pair, the x is our side. It goes in for that first piece. Then we want an equal sign. Our other two sides, remember B and C here are just our other two numbers in our triangle. 9 squared plus 16 squared. Then minus 2 times 9 times 16 times the cosine of the angle, in this case is 80. Now with x being on the left by itself here, we can type this whole thing in on the right. So 9 squared plus 16 squared minus 2 times 9 times 16 cosine 80. Okay, remember this isn't quite done because it still says x squared over there. So we're going to round to 4 decimal places since we're not quite done, and then take the square root of that. $16.9. All right. What I want you to do right now is pause the video and try number 4. Okay, we've done quite a few examples of different types of triangles. We're still solving for a side TA, so I want you to try this one on your own. For this one, x went by itself again, law of cosines, because we don't have enough angles. And then our angle that was with our pair goes over here with cosine 120. Type the whole thing in to get 1399 and take the square root. So that missing side is 37.4. Now with the law of cosines, we don't have enough angles in our picture to really check. What we can do though is think about the other two sides we're working with here, 18 and 25. Okay, the numbers should be reasonably close to those values. And if you have an obtuse angle, that will tell you that your x is the biggest side. Okay, over here we had 80 degrees. Okay, we don't know about these other two angles, so we can't guarantee it's the biggest side, but 80 is a larger number. It's reasonably close to the other two, so we're okay. Now, for the first time, we're going to solve for an angle. Okay, it says find the measure of angle A. So in A, we put an x. Now this tells you we're finding an angle, and x is on the inside. We're going to have to use the inverse at some point in this problem. Okay, so make yourself a little note of that. When you solve for an angle, when you see that's what's missing, you have to use the inverse at the end. Okay, so the other steps stay the same. Okay, we want to mark our pair because looking in here, once again, we only have one angle given to us. If we have 95 degrees being our only angle, we can't solve for the others to decide whether this is a right triangle. Okay, once again, another thing you can look at, anytime you have 95 degrees or an obtuse angle, cannot be a right triangle. All right, so now we have our one pair. We want to see if we can choose another, and we can here. So that tells us law of sines. In this case, we want the angles on top since we are putting our x on the inside here if we're solving for an angle. So angles over sides this time. That looks like sine of x over 19 equals sine of 95 over 28. What you just want to make sure of here is if you put sine on top, it should stay on top all the way through. If you put sine on the bottom, sine should stay on the bottom all the way through. We want to get x by itself, so first we're going to multiply by that denominator, 19. And you'll notice over here we still have sine x. So we want to bring that whole thing down. But on this side, we can go ahead and type that in. It should look like an ugly decimal because remember what we first said here is we have to take the inverse last. Okay, now looking at this decimal, we've got 6759, but that 9 should go up because of the 8, so we'll round it to 60 here. Then, using the inverse of that number, we get 42.5 as our answer. It says the measure of the angle, so we want to make sure that we put degrees on there. Sorry, that's a 0.5. Alright. Number 6 is also solving for an angle, but this one they don't tell us which one. It just says, find the measure of the smallest angle. Well, with our triangles, we can kind of check that we're doing something right. We've been looking at the angles across here. If I go ahead and put this 42.5 in, you'll notice 42.5 is smaller than 95, so 19 is smaller than 28. With that in mind over here, if we want the smallest angle, we should look for the smallest side. Well, we know out of 12, 7, and the blank hypotenuse, 7 has to be the smallest side. So then across from that will be the smallest angle, our x. Now that we have x in the picture, we want to decide if we're using SOHCAHTOA, the law of sines, or the law of cosines. Our first question on all of these is it a right triangle? You'll notice here it is. So this is a SOHCAHTOA problem. Okay? If you haven't already, you need to learn the SOHCAHTOA because you'll need to know that for the test. Okay? With SOHCAHTOA, you always mark your angle, the acute angle that you're working with. So in this case, it's x, and then you label the other pieces that are already on the triangle. Okay, so we only want to label the 12 and the 7 in terms of this other letters, the opposite, adjacent, hypotenuse. So 12 here is next to or adjacent. The 7 is across from or opposite. So we're using the TOA, which means tangent. For each of these, sine, cosine, or tangent, okay, you always want to write the angle next to it. So our angle here is x, and then we're equal to opposite over adjacent, so 7 over 12. Once again, this is the measure of an angle, which means we have to use the inverse for the last step. This time, since it says tangent x, we're using the inverse tangent of the 7 over 12. And that gives us 30.3 degrees. Number 7 is an angle again, so we'll have to use the inverse at some point. And it's specifically angle K, so in there we need an X. Now for this one, we don't have any other angles given to us, so we cannot assume it is a right triangle. We have to pick our pair. 15 goes with x in this picture. Now we want to decide law of sines or law of cosines since it's not a right triangle. There's our one pair. You'll notice the picture doesn't have any other angles, which means we can't pick any other pairs, so we're stuck with the law of cosines. Remember, the formula looks like x squared equals b squared plus c squared minus 2 times b times c times the cosine of our angle, big X. Okay, that is on your cheat sheet. With law of cosines, the side always comes first. So in this pair, the side is the 15. So we'll say 15 squared equals, the other letters B and C represent our two side lengths, 13 squared and 14 squared. Then minus 2 times those same numbers again, 13 and 14. And then times cosine of x. Now, since we're trying to solve for x and it's a part of this big mess here, we want to make sure that we split up the things that look like each other. All of these are squared, so we want to put them on the same side. Remember, this says positive, so we subtract it over. This says positive, so we subtract it over. 15 squared minus 13 squared minus 14 squared. Then we just write what's left. Negative 2 times 13 times 14 times cosine of x. At this point, we get to go ahead and simplify. So we can say 15 squared in our calculator minus 13 squared minus 14 squared. And we get negative 140. Most of the time this is a negative number, but it could be positive. Over on the right-hand side, we have negative 2 times 13 times 14. Because of that negative in the front, this right-hand side always has to be negative. Now, from here, it says times, so to get rid of this negative 364, we divide. That's calculator stuff again. Now, we see a really ugly decimal here because that's cosine of x. It's equal to this mess, 3846. But remember, we said we had to use the inverse, and that's our last step. We're going to use the inverse cosine, since that's what we see, of that 0.3846. Remember, since we are solving for an angle, we have to make sure we label our answer with a degree sign. Alright, what I want you to do now is look at number 8 here. It says find the measure of the smallest angle. So we're using the inverse again. But just like with number 5, where we had to find the smallest angle, and we used the smallest side, we have to make sure our x is in the right place on this one. So on number 8, the smallest angle has to be across from the smallest side. We've got 336, 385, and 511. So our smallest side is at the top, which means our x goes with this letter O. Alright, at this point, I want you to pause the video and try to solve for x here. Remember, your last step will be using the inverse. Alright, so we want to make sure that our 336 is by itself in the law of cosines, just like last time. Okay, and then our x is way over here, which means we have to subtract some stuff over. If you didn't get this 41.1 like I did, check this number and this number. Okay, that'll tell you if you maybe typed something in wrong. And then remember, we have to take the inverse at the very end to get our angle measure. Now we're going to just do a couple word problems applying the law of sines and law of cosines. So it says, some students in geometry were assigned the task of measuring the distance between two trees separated by a swamp. They determined that the angle formed by tree A, so A is a tree, and a dry point C, so C over here is a dry point, and tree B was 27. So this is a tree again. Now, we usually talk about angles like measure of angle A, but we can also say measure of angle BAC. We can use 3 letters. Anytime we use 3 separate points, it's the one in the middle where it counts. So here, If it says the angle formed by point A, point C, and point B was 27, it's the one in the middle that's our vertex. That's the one that counts. So 27 goes by C. Alright, then it also says that measure of angle ABC was 85, so remember again the middle one is what counts, so angle B is 85 degrees. And then AC, the length, was 150. How far apart are the trees? So if we're solving for between the trees, we need an X right there. Once again, we want to decide if this is a right triangle, so 180 minus 85 minus 27, just to check. It says 68 degrees, okay, so it's not a right triangle. So we'll pick our pair and try to choose another. So in this picture, we can choose another one. So this means law of sines. We're starting with X, our unknown on top, and that means sides are on top. So we'll have X over the sine of 27 equals 150 over sine of 85. To solve this, we just have to multiply by that sine 27 on both sides. And we get to type it in. So 150 divided by sine 85, and then times by sine 27. So X is approximately 68.4. Label here is feet. Now, hopefully that makes sense to you because 85 was our big angle, so it's across from the big side. And then 27 is our small angle, so this should be smaller than 150, and it is. All right. For the next one, it says two outlook towers L and M are 50 kilometers apart. So from L to M, we have 50 kilometers. Anytime you have a distance, it's telling you a side length. Then it says the ranger in Tower L saw a fire at point C. So now we need point C somewhere. Doesn't really matter where you draw it, but think we're trying to make a triangle here. Okay, so make it close enough where you can connect the points to make a triangle. All right, then it says the measure of the angle CLM is 40. Remember, 40 goes in for the middle vertex piece. Then it says the ranger in Tower M saw the fire such that CML is 65. This time the middle letter is M, so 65 degrees next to that. It says how far was the fire from Tower L? So from fire to L, that's what we're trying to find X. How far tells me a side. So we've drawn our picture, now we want to solve. With this information, okay, I want you to figure out whether this is a right triangle to use SOHCAHTOA, law of sines, or law of cosines to solve for X. Pause the video and get that done. We're using law of sines because that missing angle was not 90 degrees. And then our first pair, X goes with 65, second pair, 50, and 75 go together. Multiplying by sine of 65 on both sides, we get 46.9 kilometers. Okay, that makes sense because 65 is smaller than 75, so our answer should be smaller than that 50. Last problem here, we've got a drawing. Says points S and T are the endpoints of a tunnel through a mountain. So here's our tunnel going through this mountain by this little squiggly thing. Says from point Q away from the mountain, it's possible for a surveyor to see both points S and T. So our surveyor is over here. They find that QS is 720 meters and QT is 510 meters. Then the angle SQT is 84.5. Remember that means Q in the middle gets to be 84.5. Now they did you a favor here to solve or to put everything on your triangle here and draw it for you. Sometimes that'll be done for you. Sometimes you have to figure it out yourself. Okay, so it's good to look at these pictures and talk through where these numbers are coming from. Now it says find the length of the tunnel. Remember our tunnel was going through our mountain here, so we have to find that for our x. Okay. Now that the triangle is set up, you should be able to decide whether this is a right triangle to use SOHCAHTOA or whether we have to use law of sines or law of cosines. Okay, so here, hopefully you see it's not a 90 triangle. We don't have enough information to determine those angles. We pick our pair, and there's no other pair in here, so we have to use the law of cosines. All right, in our pair for law of cosines, sides always comes first. Our side is x, so this stays x squared. Then we've got 510 squared plus 720 squared minus 2 times those numbers again. And our angle is 84.5. We're trying to solve for x. It's alone, so we get to type in all that other junk on the right-hand side. Big number, but that's okay. Not our final answer. X squared is 708,110.8793. And then we take the square root of that for our final answer, and hopefully it'll be a lot closer to the 510 and the 720 that we were given originally. Okay, that seems reasonable. So our answer here, 841.5 meters, is the length of that tunnel. All right. Your homework will be an assortment of law of sines, law of cosines, and SOHCAHTOA problems. Come see me if you have any questions.